This is structured water, and this is insane. This is just insane. So let's get into it. So there's cations, which are positively charged elements, and then there's anions, which are negatively charged elements. So for cations, some examples are magnesium, which has a +2 charge, potassium, which has a +1 charge. Anions, some things like this are SO4, which is -2, and then what's another one? Forget. Chlorine. Okay, so these attract one another, right? Positively, cations attract anions, and likewise, positive attracts negative, negative attracts positive. But each of them essentially orient in a certain way. So like we went over last time, magnesium has this +2 charge, right? And so it will bind to these H2Os, and it can take up to 6 of them. For example, sulfate, SO4, basically is oriented like this. So there's a sulfur in the middle, and then there's a tetrahedral structure. So you can imagine this 3D-wise as a pyramid, right? And then this is like kind of a cone. You have an oxygen, 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 oxygen. So the reason that this is important and how it structures water is that oxygens attract other hydrogens. So when you have an H2O binding to it, it doesn't just look like that. It looks like this. H-O. And you can start to see how we'll have this incredible ordering of molecules. Now, these are very tight, right? Magnesium is very tight. K, on the other hand, is not as tight because it has a +1 instead of a +2. So like you have your K, and the difference between this, which is a net negative, right? Hydrogen is positive. It attracts to the oxygen. That's why it orients like this. K will attract the negative. So now when it binds to these H2Os, you see it bind like this. Now the oxygen coming off the hydrogen, right? Oxygen, hydrogen, hydrogen. We're seeing? Okay. The thing about this, though, is when they're not in as tight of shells, they're actually in motion. So this is a super small radius, and this is like 2 atomic lengths. So there's hardly ever any switching. What's happening in the sulfur bond is, so the next level of complexity is that 2 of these are net negatively charged, these oxygens. They're negative, and they attract these like this. These can each of these oxygens can take 4 to 5 H2Os. Okay, so these 2 can take 4 to 5 each. It's 10. These are single bonds. These are double bonds. Okay? Now what does this mean? It means that they're essentially dipoles of the molecule, which means that, for example, they're going to be less likely to exchange. So what happens when hydrogen bonding happens, which is when, so as these are going, basically these oxygens can exchange other hydrogens for other oxygens as long as it balances, right? So like, for whatever reason, this just happens because it's a dynamic process. Like this hydrogen will switch with this hydrogen, or they'll both switch hydrogens, or the oxygen will switch. And when you're in a system where there's actually things being added, there's oxygen being added, this happens a lot faster. It's very frequent. So what happens when there's this dipole is that these oxygens will be passing, or these waters will be passing by, right? So they're flowing. And now, say this is your H2O, and it's oriented like this. It will rotate because the hydrogen is attracted to the oxygen. Now this seems trivial, but it's not, because all of a sudden, what just happened was it's creating an electric current. So, since this acts as a dipole, it creates a magnetic field. Since these hydrogens are shifting their structure, shifting around it, it spirals up through it. And it creates, if you want to visualize it, it creates this, we can draw it again. It creates essentially this magnetic field which coils around the structure. Looks like a crystal, huh? So this is, as you know, magnetic fields. This is generating, so this is the B field, is generating an electric current running through the center of this, which is creating, out of nothing, creating an electric field. And this is the living water that Jesus talked about. This is the alive water. I'm at a loss for words, honestly, with this shit. But I'm gonna make it happen. Okay, so this is all very interesting, but how does this manifest? So, how do I explain this? So, there's something called a hydrophilic surface, which is all through your body. Many things are hydrophilic surfaces, like collagen is hydrophilic, which just means it repels water. So, the reason that these are important in your body, the magnesium, the sulfur, is because it allows free ions to travel. So, what are some examples? Like the mitochondria. So imagine this is your mitochondria. There's a layer of it, right, which is the cellular membrane, which is filled with proteins, which are positively charged, okay? They're proteins and they're positively charged, which creates a proton gradient. This means that this is a net positive field. Around it, there's this net negative field, which is it's a hydrophilic surface. This is where this negatively charged water will accumulate. What happens when there's a surface of positively charged and negatively charged? It creates an electric field between them. This is your body's way of creating electrical energy. Just like that. There's a voltage potential. And there's many other parts of your body that are hydrophilic. It's all kind of interconnected. But also, the H2O molecules will align on hydrophilic surfaces into hexagonal structures. Okay? So this will be H2O. This will be H2O. H2O. And then something happens called pi. Okay, first of all, these are hydrogen bonding, so they're switching. This is an active process, and this is a hydrophilic surface, right? But what happens is there's this thing called pi bonding, where it creates another surface directly on top of it, another hexagon. Connect them. These also have H2Os on them. So what happens all of a sudden is you create this lattice, right? You can imagine this lattice, hexagonal lattice, that is creating this massive electric field, right? Because there's electric potential running all throughout it. There's a magnetic potential running all throughout it. And what happens, this is the beautiful part. What happens is, all right, I'm gonna erase this once we got it. Let me erase, okay. I'm gonna erase over here. So what happens is, in this process, you can imagine this, how do I even draw this? 1, 2, 3, 4, 5, 6, okay. So you can imagine this thing, boom, 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 okay. Blah, blah, blah. So these H2Os, you can imagine, are essentially circling it. H2O. In this process, there are hydrogens being basically input into your body. Hydrogen is much more common at kind of, your body has proton gradients which produce hydrogen naturally. Your body uses a lot of electrons, a lot of negative charge, and it produces a lot of hydrogen charge. So there's excess. There's hydrogen flowing through this lattice, right? And since these are all H2Os, what happens with hydrogen bonding? It kicks out, it can exchange hydrogen for other hydrogens within the oxygen and within the H2O molecule. So it starts kicking out hydrogens. It starts kicking out hydrogens. Janky ass setup. It starts kicking out hydrogens as more circulate. Now, these hydrogens don't go anywhere. They start surrounding it. This becomes an accumulation layer. And this, so imagine they're all around, they're on this side too. What does that mean if it starts kicking hydrogens out? Like just naturally in the process? And it'll start kicking out more and more and more because this lattice structure gets more and more stable. The hydrogens give their energy, then the oxygen can sustain the structure. So it starts kicking out these hydrogens. You have a field of positive charge here, and this hexagonal lattice becomes a negative charge. This is your hydrophilic surface, this is your proton gradient, and all of a sudden, there is a sustained electric field, an electric potential with a voltage in between the two. This happens at all your hydrophilic surfaces. This happens with your skin. This happens, around in your blood vessels, through your organs, through your heart, everywhere. It's going like this. And this is, I don't know. I don't know fucking words. You can you can see I don't have words for this. There's these ways, basically, for example, some things like silica. Let's look at how it works with silica. So for silica, you have this compound SiOH form, okay? So you have this silica, and you have it, again, tetrahedrally bonded to OH groups. And we're going to look at how this manifests again, because this is happening everywhere. So since this is OH, you can actually, it's kind of better to draw it like this, so you can see it better. There's an O and there's an H. So there's H2Os, there's H2Os circling everywhere, H2Os circling everywhere, boo, 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 boo. Okay, also this is what is H320. This is the thing they're talking about. Because there's this excess, right? There's the excess hydrogen, essentially, that's giving. Sustaining the potential. Okay, so there's H2Os going about. You have your hydrogen. This is going to attract the oxygen, while this is going to attract the hydrogen from this. Then there's also this hydrogen. Each of these OH groups can take on 3 H2Os. So why does silica help your hair? Why do these silica compounds help with bones, with teeth, with nerves? Because they're taking on more of these H320s, circulating them, right? Going through this hydrogen bonding process, and and essentially ordering your body. It's bringing order to something that lacks order. And it's living, it's constantly circulating, creating this electric potential, this gradient that is sustaining everything. I'm trying to think if I forgot anything, but I don't think so. That's basically the wraps of it. But yeah, so this sulfate, this SO4 sulfate, potassium, magnesium, chlorine, but really some of these other things, the silica is highly important, and some other stuff is completely necessary for hydration. It's completely necessary for your body to survive, for your body to exist as this living thing, the living water. This is it. Yeah, I don't know, I'm kind of blown away. This is unreal. So, hope you all enjoyed. I'm gonna do more content on this, but holy shit.